Okay, a quick look at something new coming in Schematic. I'm adding to Schematic open source simulators, and the first one I have added is NGSpice. So this is the standard schematic frame that you'll be used to, and I'm just going to press play on this transient simulation, and running now is NGSpice. So NGSpice is available open source, and it's really quite quick. It's not as accurate as SmartSpice unless you tighten up the tolerances a lot, but the way I'm interfacing with it from the schematic actually runs really quite quickly. All of the things that you're familiar with are still working. I will mention a couple of things. Oddly, in NGSpice, if you save nothing like that, that saves everything. So if I run this simulation again now, for instance, we will correctly find that data for the current consumption. And as you can see, it responds really quite quickly. If I run an operating point now in NGSpice by just typing it down there. By the way, down there just works like before. You can type Lisp forms and it returns Lisp, or you can type commands to NGSpice, in which case it prints the commands, or you can do all the, you can do everything up here as well. So let's just run this again now with a slightly longer time. How about I give it a little bit of a more difficult problem, run for a little bit longer. NGSpice is running now, and after it's run, it'll plot again for us. There we go. There we go. And all the plots just work. Everything works just like you're used to with SmartSpice, but it's NGSpice underneath. NGSpice requires every parameter to be surrounded by single quotes like that, so it's a little bit less convenient, I suspect. When it's DVCC over 2, like it is in this AC analysis, SmartSpice would have required that as well. Let's just run a quick AC analysis here. It works just the way you'd expect. There you go, and then you can plot the output here. Plot this guy. Sorry, missed. Here's the wire. Oh, missed again. Plot. It's because this recording program is running, it's not quite as swift with the mouse. Plot this guy, and this should be the AC response. There it is. Now, as I mentioned, if you do an operating point, if an operating point is available, the new version of the schematic does something a little bit more interesting. It shows you those operating points as a tooltip. A 1.25, Y 2.313. It also shows you the flat net list. So for example, in a much more complicated example such as this one, if you move over this wire, for instance here, it will show you what the flat name of that wire is. U1 ground, that one there is you can see what it's doing. It's showing you the names of the nodes, so you don't have to drop down a permanent marker. You can just look around. That element was marked as simulators are empty. You can also mark these things. For example, if I notate this guy, I can now say what this is. I can say this is the ADC core, which is marked to not spice, for example, to no spice, close enough. And then when you move over this thing, it will tell you there, look, this is the ADC core marked to no spice. So you can look around and see what the designer's intention was. This one is inverter drawn oddly. Not that that matters too much, but you see a few more little helpful features like that, and I think you'll particularly like this ability to points without dropping a marker. It certainly helps me as I'm looking around. And it's all working with NGSpice, which is open source, and so you don't have to pay big bucks for SmartSpice or any of the other alternatives that you might like. Okay, I'm going to add size to it, and I'm going to add LTSpice to it as well, because I have the substrate in place now for communicating with any arbitrary simulator program.